Good. Okay. So this is not a talk about AdaCore going into the Botox business. Do people know, how many people here are familiar with FACE? A few? Okay. So what I'll be covering is a bit, very briefly, what the FACE standard is about. Also why it's important, why it's relevant to AdaCore and our customers, and what we're doing to help the effort along. So first, what is FACE? Well, I first saw the acronym, and obviously this is the forever Ada capability environment, right? What could be more apt than that? Well, not quite. So actually, the FACE acronym stands for the Future Airborne Capability Environment. Well, that's kind of cool. So aside from kind of a fierce-looking logo and a clever acronym, what's it about? Well, so very briefly, FACE is an initiative. It's a collaborative approach, mostly between government and industry, although there's some academics involved also. The idea is to reduce the lifecycle costs for airborne software. Well, there's several ways to reduce lifecycle costs. We could want the software to be more reliable and therefore less expensive when we go to test and verify it, but that's actually not the emphasis here. The focus of FACE is really on component portability. Take things like flight management systems, write the source code, recompile it, and then redeploy it in some other FACE conformant environment. So basically, it's an initiative intending for portability or reuse. It does not guarantee anything about fitness of purpose, whether it satisfies various assurance requirements. It really is portability. Well, we've seen this before, right? I see some other white-haired folks in the audience. I remember STARS from the mid-'80s. So what's different about FACE? Well, I mean, one of the differences, this actually is collaborative. It's supposed to be more bottom-up rather than a top-down initiative, which is being imposed upon us by DoD. The major stakeholders are involved. Open standards are involved. So presumably this will be a bit more successful than some of the previous initiatives. FACE really comprises a couple of aspects. On the technical side, there's a reference architecture that looks like a traditional layered architecture with separation of concerns. On the business side, there is a conformance policy. What does it mean if you have an avionics component or an RTOS? What does it mean to conform to the FACE standard? I'll be talking a bit on the technical side today. Doug Smith can give you maybe more than you want to know about on the business side, what's going on with the conformance policy. This is an open standard. There's a website. It's actually under the auspices of the Open Group website, opengroup.us/FACE. The documentation, I believe, is accessible. You don't need to be a member of the FACE Consortium in order to access them. So here's a simplified version of what a FACE platform might look like. Let's see, this is... so you have FACE applications, which has some business logic. They're doing whatever they're supposed to be doing, flight management or whatever. They might be communicating with some other FACE applications through a well-defined interface. It's called the transport system segment. This is like a Corba-like interface where these data that's being transferred or communicated will be specified at some level in IDL. So the FACE application might be doing some communication, there's some business, and there's also some runtime services that might be required. Memory allocation, threading, exceptions, and so on. You can actually get those runtime services through various mechanisms. One is through calls on an API. So there's profiles that are defined in FACE for POSIX, and also ARINC 653 is supported. Or it can also get runtime services through language facilities. These are known as capability sets. So for example, if you want to use concurrency, you can get concurrency by using pthreads, or in Ada, say, you could get concurrency using Ada tasking. That will in turn map to language runtimes. So the language runtime libraries are considered to be part of what's called the operating system segment, together with the other operating system services. The thread support, partition support, fault tolerance, and so on. And these in turn would call on some low-level platform-dependent services. So very briefly, that's what a FACE environment might look like. So there's the term language capability sets. What's that about? Okay, well, there's a recognition in FACE, even though there's nothing in the FACE standard about complying with the various safety or security standards, there's a recognition that different components might have different assurance requirements. So in particular, the FACE standard defines what are called profiles. These are subsets of the operating system's API that will support various levels of assurance, and also language subsets called capability sets that correspond to what are in those API profiles. So if there's various runtime services in the profiles, there'd be a corresponding language subset that would map to those runtime profiles. Earlier versions of the FACE standard used the term profile for both the language and the API. That was a bit confusing, so now there's different jargon depending upon whether you're talking about the API or the language features. So the profiles vary based on the requirements for partitioning, for determinism, and also for assurance. There's actually three general levels, three general profiles: general purpose, safety, and security, where safety for various historic purposes is divided into base and extended. At the lowest level, or the most constrained level, is security, which requires time and space partitioning, real-time determinism, schedulability, and also conformance with whatever the appropriate standard might be, for example, EAL6 under the Crommen criteria. The safety profiles and safety profile subsets of the API would also require time and space partitioning, and also real-time determinism, schedulability, and assurance, whatever the appropriate standard might be. It might be a DIA 178B, level A or level B. General purpose actually does require space partitioning, but not necessarily time partitioning, and no specific requirements in terms of real-time determinism, and it's really whatever the relevant standard would be for assurance. And there's kind of corresponding capability sets that are defined for, I guess, 4 languages. For C, it's the C99 standard. For C++, it's C++, I think it's 2003. For the Ada standard, it's Ada 95 with a little bit of Ada 2012, and I'll talk about that in a moment. And for Java, I think it was the Java Standard Edition 7 or 8, goes back to around 2013, 2014. So there's a rough correspondence between the capability sets and the profiles, or general purpose capability sets. There's a safety extended set, and the safety base and security are kind of lumped into one. So how does this all relate to AdaCore? Well, in a couple of ways. We have seen FACE interest from our customers who are developing avionics applications. FACE is starting to show up a bit in requests for proposals. There was a recent one that got publicized by the Open Group. I think the KC-130J procurement mentioned the FACE standard. It's not required, but at least you're getting into the procurements, and that will, I think, perk up the interest from some of our customers and also our partners, in particular Wind River and Link Software Technologies. Both have RTOSs. In Wind River's case, it's actually been certified as conformant with the FACE, one of the FACE technical standards, and Link's, I think, is working on it. So there's definitely interest from those parties. It relates to us because Ada is involved, and indeed there's some Ada language support in the FACE technical standard, first in the capability sets, and then also on the data side, there is a mapping from IDL to Ada. I think if there's time, there's a little example that I'll show later on how we've addressed what was an interesting technical issue in that mapping from IDL to Ada. What are we doing about it? Well, we have FACE support in our products in various ways. Maybe most directly, we have a couple of runtime libraries that indeed implement the features that are required in the various capability sets, and indeed in those API profiles. So, for example, the CERT, which I'll talk about briefly later, it's a kind of a sequential subset which has some simple support for various runtime features. And also the Ravenscar cert, which adds Ravenscar support. And both of those actually fully implement the features that are required in the corresponding safety and security capability sets. So on one side, we have libraries that will implement the required functionality. We also have a tool called GNATCheck. Actually, it's kind of useful that maybe I'm giving this talk before the break. Rob has a nice demo showing how GNATCheck can be used to actually enforce some of the restrictions that are in the safety and security capability set, because these are subsets that are required. If you want to conform at the application level, you have to make sure you don't use features outside that subset. GNAT check can help you in that area. And then finally, there's a conformance policy. We would like at some point to say, hey, our runtime libraries conform with the FACE requirements. And there's still work underway to figure out exactly, or to decide exactly what that means. How does a runtime library conform with the FACE standard when the runtime library is considered part of the operating system segment? So that work is kind of still underway. Again, Dud is your man to talk to about that. A little bit about the capability sets. So first in ADA95, the general purpose capability set for ADA95 covers most of the language. It doesn't include asynchronous transfer of control, doesn't include I/O because there's specified API for I/O in FACE. Restriction on some of the implementation defined pragmas, but it's really most of ADA95. Safety extended profile restricts that a bit. Well, more than a bit. In particular, instead of full ADA tasking, there's the Ravenscar subset, which is supported. Or if you don't want to use the ADA tasking and Ravenscar, you can also use POSIX API. Most of exception handling is supported. There's some restrictions in some of the implementation defined functions and ADA.exceptions. And with memory management, dynamic allocation is supported, but only during the elaboration process. After package elaboration, then no further allocations are allowed, and there's no unchecked deallocation. The safety base and security is the safety extended with some additional restrictions. In particular, instead of having general exception handling, you have a last chance handler that can capture unhandled exceptions, and no dynamic allocation at all. That's actually overly strict. If you look at the C++ capability set for safety base and security, actually in C++, allocation is permitted. So it's a bit odd that it would not be permitted on the ADA side unless whoever wrote this didn't want ADA to be used. Let's think about that one. Which then kind of gets me to the ADA 2012 capability sets. This one's interesting. So what would you expect in the ADA 2012 general purpose capability set? Well, I mean, the most obvious feature is contracts. I mean, that was really the game changer in ADA 2012, right? That's what should be in there. It's excluded. Wow. Well, what's in there then? Well, we have static subtypes. Well, thank you very much. I mean, it's a bit like saying, hey, I have a gift certificate for Davio's Northern Italian Steakhouse. It's in Boston and New York. But there's an asterisk on that. You can go to the steakhouse, but you can't order anything which is Northern Italian or steak. Fine, I'll have mac and cheese at the Davio Steakhouse. So it's a little bit about what's going on there. And then there's no support for either of the safety profiles. So that is just kind of, I wouldn't say maybe weird, but unusual, shall we say. Unless, again, whoever wrote this didn't want ADA to be used. I mean, how could that happen? So certainly we've been very active in working on a profile which we're proposing to be added to the next version of the FACE standard, which actually will be a bit more respectable in terms of the support for ADA 2012. So we're not going to do anything with the ADA 95 capability sets. There's actually some inconsistencies in there. It's a bit weird, but I will kind of leave that alone. ADA 2012, clearly we want to add contract-based programming, and indeed, the way that we're going to propose this is, well, you have all of ADA 2012 except for some of the stuff which you don't want to have. I mean, some of the machine-dependent, some of the pragmas, for example, that might be implementation-dependent. So we're proposing something which kind of looks like the ADA 95 capability sets, but with restrictions that are comparable to those of ADA 95. Some of the predefined environment, for example, you don't have I/O, you don't have the information systems annex, and so on. So the safety extended and general purpose for ADA 2012, again, it'll be based on ADA 2012 with kind of comparable restrictions to ADA 95. The one that's going to be, we're proposing something a bit different, is with safety base and security. Indeed, our experience has been, both from the point of view of users of our runtime libraries and avionics applications in general, that more general exception handling actually makes sense. And also, there's no reason to completely disallow dynamic allocation. So indeed, for ADA 2012, the safety extended and the safety based security will look pretty much the same. And there's also some things I guess I forgot to mention. Secondary stacks are supported. You have to specify what the max size is, et cetera. But I think we have some good rationale for adding these ADA 2012 capability sets to the next standard with support from our avionics customers. There are customers out there that are using ADA 2012 very successfully. Their coding standards allow contract-based programming and other features. Clearly, if the user community is asking for it, then it really makes no technical sense to not allow it. And then kind of a bit on this point. So there was a recent report from the Defense Innovation Board talking about software development. It really focuses kind of on various aspects of the whole software lifecycle. But one of their do's was interesting. It said, use modern languages and operating systems. Well, what could be more modern than ADA 2012? Well, ADA 2020, but that's not quite here yet. So certainly ADA 2012 directly supports this do. This is not any attempt to diss ADA 95. I mean, it was kind of a fantastic language. Thank you, Tuck. It was a very good increment over ADA 83. But let's face it, it's 25 years old, and there's been progress since then. We have some good stuff going on. So ADA 2012 definitely is a language that, with the contracts and some of the other features, supports this do, and we will be promoting this in the FACE Consortium. I mentioned the capability sets, and they do have, well, at least especially the safety and security ones, have a set of restrictions. So how is that enforced? Well, actually, ADA does a pretty good job here. There's pragma restrictions. With pragma restrictions, you can specify things you don't want to have in your code, and if they occur, then almost all of these are compile time checks. In some cases, it's runtime. So, for example, no standard allocators after elaboration? I mean, that would directly support the capability set restriction that says no allocators after elaboration. Pragma profile Ravenscar was added in ADA 2012. That bundles up a bunch of restrictions to ensure adherence with the deterministic Ravenscar subset. And then finally, as I mentioned, the GNAT check tool, again, a little plug there for Rob's demo, can be used to enforce many of the restrictions that are in these capability sets. This was an interesting, a minute or two, just interesting technical issue that we faced. IDL is used in kind of the data interfacing part of the FACE standard. I don't know if this got clipped a bit, but there was a kind of an annoyance where what was perfectly legal IDL couldn't map cleanly to ADA. And the issue kind of shows this. We have a module in IDL that defines foo as a type or a type def. Module B then makes use of that. And then module A is called a reopening. So a module can be specified in several syntactic steps in IDL. And then this can then reference the type that was then added in B. Well, if you try to, the original IDL mapping said, well, these modules just map to ADA packages. Well, it's not quite so simple, because if you look at the dependencies here, B depends on A, but the reopened A depends on B. And if you try to write this simply as ADA packages, you get circularities. Well, that's kind of annoying, and we certainly don't want ADA to be at a disadvantage when it comes to FACE and IDL mapping. So this was about a year ago, I think, and the issue came up to AdaCore, and let's say it was Tuck, Toma Aquino, actually Cyril Komor, one of the founders, and myself kind of did some huddling, and we actually came up with kind of a nice solution here, where if you're say the IDL module compiler, you can map each one of these modules to a package. A reopened module corresponds to a child package. Well, you don't want the application to do withing of all these reopened packages, because that could be kind of annoying. But then it turns out that the combination of those child packages plus some renaming declarations allows you to have a single package that gets used by your FACE application, and all these auxiliary packages are kind of behind the scenes. So that presents a kind of a nice, clean solution to this, and allows ADA to be a first-class citizen with FACE in connection with the IDL mapping. So that was kind of neat, interesting technical. So I mentioned the runtime libraries. We have actually some documentation on this, but when we came up with our runtime library design, there were a couple of criteria. One was in order for a feature to be in there, it should be used in existing code and have some justifiable certification costs. So as an example, there's a package, Ada.characters.latin1, which is just a collection of constants. So that seems kind of innocent. I mean, should that be supported? Well, no, and it turns out because, first of all, it is rarely, if ever, used in avionics code. And second, it actually does have certification costs. I mean, there's constants, but they have to be tested. So the Ada.characters.latin1, which sounds like an innocent package, actually is not part of this. On the other hand, there are features that are supported because they have no runtime costs. So dynamic dispatching, for example, there's no problem with using dynamic dispatching in connection with one of these libraries because there's no runtime associated with it. You might have issues convincing the certification authorities that it's okay, but as far as the runtime library is concerned, it's fine. In any event, and I'll just cover these briefly. I think Pat may have talked about these one of the previous tech days, but the assert profile is a simple sequential, simple runtime for sequential Ada. If you want concurrency, you can use the Apex bindings. Simple memory management with kind of a wrapper on malloc. Actually, most exception handling is supported because, again, as I mentioned, we've seen this in actual application code. Lots of restrictions on the predef library. And then if you want to use Ada tasking, then there's the Ravenscar cert library, which is basically cert plus Ravenscar. And then, of course, full Ada, which would be the general purpose capability set. And indeed, actually, both cert and Ravenscar cert support both the safety base and security as well as safety extended. You get the safety base and security from cert through the Apex bindings for concurrency, and you can get it through Ravenscar with a Ravenscar cert. So summing up, yes, AdaCore does support the FACE effort. We've been actively participating in the FACE Consortium. Dud, I think, has been maybe the most active, attending both the business and the technical working groups. And more recently, I've also gotten involved in it. There was a technical interchange meeting. There was one in Huntsville in September that we found very successful. Did some demos there. I think Jamie, Rob, Pat, Dud were there. Extremely successful. Very, very nice meeting. I think we're intending to go there again next year. We provide, as I just said, we provide runtime libraries that indeed meet both the FACE portability requirements as well as the certification requirements. These have been certified to DIA 178B, level A. Wind River for VxWorks 653, 2.5. That is the version of the RTOS that has been certified as FACE conformant to the FACE 2.0 standard. And our library also works on the V3. And also the Lynx OS 178, those libraries, the cert and Ravenscar cert are also available on those platforms. And then finally, we really want to make sure that the Ada advantages are really being fully recognized in the FACE standard. One was, as I mentioned, the IDL to Ada mapping, and then somewhat more significantly, making sure that we get Ada 2012 into the next version of FACE. I mean, from our perspective, you have avionics programmers that really need to meet 21st century challenges. Let's give them 21st century technology to solve their problems. So that's what we're trying to do here. And then there's some references. There's a few articles that I put together with Dud and Pat. I'll leave this up for a bit. They appeared in Mill Embedded. Actually, one of them I think is just coming out. And the other one was actually published in the FACE proceedings. So if you want additional information on libraries and our support for FACE, feel free to access any of these. Okay, how did I do? Ooh, over a couple minutes, but questions?